Thank you. Yes. So today I'm going to be talking about the fascinating subject of logging, which is really a subject that should be boring, but it's boring until it's important. Still today, logs are really one of the few things you have a way to go back and say, what the heck happened? How did I get here? If you weren't running dtrace or inspecting the process as it was failing, logs are usually one of your very few ways of recreating what happened. And if you ship a product to customers, logs can be one of the only ways your customers communicate with you. You're effectively, if you write a product that a customer runs on site, your logs are you talking to the customer. So the logs need to be approachable in some way. And logging is one of those things that, as long as it's working fine, nobody cares about it, nobody pays attention to it. But when it breaks, it's like plumbing. You need to call the plumber, and the plumber needs to be here in 15 minutes because, your ceiling is spouting water. So historically, Erlang has had a very dodgy story on logging. The logger in OTP has a lot of weaknesses. I think anybody who's used it is probably intimately familiar with them. We'll cover them briefly. But, a ray of hope has appeared in OTP 21. We finally have something that is not errorlogger to look at and consider as part of an Erlang or Beam deployment. So why am I up here? Well, I have a long history with Erlang logging, going back about a decade. I tried to use errorlogger in 2008, and it was so bad I wrote my own. Then I joined Basho in 2011, and I told our customer support team about the logger I had written previously, and they were so excited that they made me write a new one for Riak, because one of the biggest pain points in the customer support was logging, and we'll cover sort of the real pain points here. And then I gave a talk about Logger at Erlang Factory 2013, maybe 2012, I forget what year it was. And I've been maintaining Logger ever since, so a wonderful 8-year history of dealing with this. And I was consulted and participated a little bit in the design of the new OTP Logger in OTP 21. I emailed with Siri Hansen at Ericsson quite a lot. So yeah, what is the problem with what we had before? Well, the big one is that errorlogger had a completely asynchronous pipeline. A process could send logs all day long for free and not pay any cost. It could just kick the can down the road all day long, and there was no back pressure, there was no, nothing. It was just a completely asynchronous pipeline. And log messages were not size truncated at all. If you had a 200 megabyte binary or even a 1 megabyte binary in your GenServer state and you crash, that 1 megabyte binary is going to be put in the log file. And Erlang is not good at printing a 1 megabyte binary. The logs that you get out of errorlogger are extremely confusing for anybody who doesn't know what Erlang is or doesn't want to know what Erlang is. It uses very dramatic terms like crash report. It scares people. They are like, oh my God, my system is falling over. And it's like, no, a socket got closed. It's fine, but crash report. The log rotation in errorlogger, I think it's using disk log, but anybody who's not, any sysadmin, I used to be a sysadmin, any sysadmin looks at that log rotation and they've never seen anything like it before, and it just makes them mad. The way the log rotation works in errorlogger is that there are n log files. Then there's an index file that in decimal, not in ASCII, holds the index of which is the active log file, and it just bumps through them. And so you either have to look at the timestamp on the log file, or you have to look at a decimal byte in a file to figure out which is the active one. It's nuts. No non-Erlang person was going to put up with this. They despise it. And my 2013 talk has more complaints about errorlogger, if you want to go back in time and see more complaints. So what did Logger try to bring to the table? One of the big problems we had at Basho was that error logger would be the cause of node failures for no real reason, because a big process crashed, and it really shouldn't take the node down. So logger's number one goal was never, ever, ever never be the fault of the node crashing. That is, everything else is secondary to that. We don't want to be the cause of failure. We wanted to try to make it look more like traditional application logs. We were shipping React to customers. Customers were like, these logs are terrifying me. I don't know how to do anything with these things. They're not, So we wanted to make it feel more like running Apache or running Nginx or running Postfix. We wanted to log things that were not giant tuples of doom, which is something that we were like, that's kind of what error logger logs is, giant tuples of doom. And sure, there's a lot of good information in there, but if you're not an Erlang, aficionado, that's not an easy thing to work with. I wanted to fix the log file rotation because I'm a sysadmin and it just made me really mad. I wanted to make it easy to use. It ships with a reasonable default configuration. I tried to keep the API as simple as I could, and I wanted it to basically do the right thing by default. I also wanted to add metadata to the logging process. Effectively, I wanted to be able to say, well, this log event is related to request ID 47, or user 32 this request pertains to user 32. And I wanted to tag the message with this kind of information, so as it flowed through the system, we kind of knew some things about how that log message was generated. I also wanted to decouple formatting the message from storing the message, so that you could format it at one place and then send that through, and then at some later point you could write it out to disk or send it over to the network or write it to the console or whatever. And I just wanted to make Erlang more palatable to ops people, so that they don't have to drink the Erlang Kool-Aid to run an Erlang service. I feel like that's a big deal. We all have the Stockholm syndrome of Erlang is just a weird thing that kind of doesn't look like a lot of other stuff, but if you want to have somebody run your Erlang service, you really shouldn't have to also have them be an Erlang fanboy, I guess. So, hindsight is 20/20. I made some mistakes. The number one, which I still don't think is a mistake, but parse transforms are a hated thing, I guess. So, back in 2011, we didn't have all these fancy new OTP features. We did not even have a function macro. You couldn't figure out what function you were logging from. It was not available. So that was why I originally added the parse transform. And then the parse transform was like, well, I can do all this other cool stuff. I can do all these neat hacks, and it just kept getting bigger, and it does a lot of cool stuff. But it's still a parse transform, and people see the red warning in the OTP documentation that says never use a parse transform. They're like, why are you using a parse transform? I don't want to use a parse transform. And I never got around to adding the logging macros for a long time. I think Tristan finally did recently. There was no reason they didn't exist. I just thought they weren't as good, so I never bothered to do it. I never got the OTP team on board. I feel like they always thought Logger was kind of a terrible thing, and from some of the stuff they've said over the years, I don't think they really understood how it worked or what it was trying to do, so never really got them on board. When Elixir came out, I missed the boat on Elixir. I talked to Jose briefly about it at, I think, the 2013 Erlang Factory, but I never really did that. I never really integrated that, and so they did their own logger, which I believe has been replaced with the new OTP logger. But basically, I never really supported anything that wasn't Erlang. And the Erlang community we never standardized on a logging API that wasn't error logger. We still had a whole bunch floating around. Logger became, I guess, probably the most prevalent one, but there was no standard way to log in Erlang. And mixing and matching libraries that supported different APIs is just a nightmare. So, and I never really got structured logging there. Kind of lots of metadata, you could kind of do it, but it never really got first-class support. And I was probably too opinionated on some things. You gotta go with you gotta make some calls sometimes, and maybe I made a few that were a little more conservative than some people might have liked. So, what about the new logger? So we have a new one in OTP 21. It's backwards compatible with our old friend errorlogger. So if you're still using errorlogger, it's going to suck a lot less. It's good. It supports multiple formatters and handlers, and they're separate things now. We'll cover sort of how the pipelines look in a minute. It supports log event metadata, which is really cool. They copied basically what Logger does. It supports report messages, which are effectively, there is no format string in these things. They are structured reports to say this thing happened, but it's not, there's no real format string. It's all just a piece of data. It has supports for lots of types of overload protection. The message is too big. There's too many log messages. We have our mailbox is too large. It turns on like synchronous messaging once the asynchronous pipeline fills up. Pretty good. It also does log event formatting in the calling process, which makes the callers have to pay for their excessive logging, which is good. And finally, it has filters so that you can control how and when messages make it through the pipeline to different endpoints. So this is, I can't overstate the fact that this is a huge advancement. Everybody on the beam is winning here because we finally have an alternative to the only other standard library logging system we've ever known. Thank you, Ericsson, for actually finally doing something about this. So they're really a lot alike. The OTP logger is a lot like mine. And it's going to get really hard because they are homonyms. They sound the same. So I'm going to try to call the OTP logger, but I may screw up, and hopefully the context will make it clear. So they both support the 7 syslog levels. Back in errorlogger, you really got 2 or maybe 3 log levels, depending on how you'd configured it. As I said, the OTP logger has all of the overload protection that logger does, both through the event format and the caller. They both have per process and per event metadata. For both systems, you can install into the process dictionary for a PID. You can say, anything that comes from this PID always include this metadata. And then at each event, you can also say, here's some extra metadata. So you can do all kinds of really interesting stuff. Like if you could put like a worker ID in a PID, and then you always know worker ID 7. You don't have to put it in every place, every call site you log. So that's really useful. And you can steer the log message based on the metadata. And actually, in the OTP logger, you can steer it based on log message format. So there are some differences. So the OTP logger does the entire formatting at the call site. Logger only does the format string arguments, and then it kind of passes the log message with all the metadata, the timestamp, a bunch of stuff through the pipeline. So it has a richer structure in the message that it passes. For each handler in the OTP logger, you do a separate format step, which means that if you have 10 handlers, you're going to run formatting 10 times. Logger, however, only does it once, and then it passes the result to each backend independently. Each handler in the OTP logger now runs as a separate process. Logger used a gen event for several backends, just like errorlogger did. And the filters are a little bit different. They're not the same as how you could trace events in logger. So here is my chicken scrawl on how I understand these different pipelines to work. We're going to cover them. Hopefully you can read this relatively well. So we'll start with our old favorite errorlogger. So in the calling process, it just literally sends everything over an asynchronous message to the gen event, which has multiple backends, or some number of backends installed into it. Each backend does the formatting and then writes it to wherever it's going. So you only have one message per event, but you do have n formats per event, and the message size is unbounded. So you potentially are sending a very large message, and then you are doing unbounded formatting in the memory space of the gen event handler, which is, if that takes a long time, then you have the mailbox growing because all this other stuff is backing up behind it. Yeah, so you can see how that would fail under load. So then logger, the formatting is done in the calling process once. Then we send a single asynchronous or synchronous message, depending on the overload state and the metadata, to the gen event. Each gen event has a backend. The backend does basically a meta formatter where it takes the main log message and then the metadata, formats that however it wants, and then writes it. So you get one message per event, one format per event. You get a bounded message size. The logger formatter does not allow you by default to make a message that is larger than 1 kilobyte. It is forbidden at compile time. And then you do, the only ON operation is doing the metadata formatting, which is relatively cheap usually. You could probably, there's probably enough rope to hang yourself there if you want to, but it's not as easy. And now we have the new OTP logger, which looks quite different. As you can see, we format in the calling process, but we do it a variable number of times. And then for each formatter, we send an asynchronous or an asynchronous or a synchronous message, depending again on the overload state, to the backend. The backend then just simply writes to wherever it's going. So we have n formats per event, we have n messages per event, and we have an unbounded message size by default. So there's, you might see there's some concern here. A lot more ON here than logger had. So we'll see some of that in a little bit here. So structured logging, this is great. This is my favorite feature of the new OTP logger by far. So basically you can log a tuple or a map, I guess, of data. It's called a report. Each report has a default formatting function applied. So effectively you attach what unless somebody else overrides it, this is how we're going to turn it into a textual piece of data. You can override it, which is great. And a huge improvement here is all OTP messages are now specified as reports. They are not format argument strings anymore. You don't have to parse the format string to figure out what kind of OTP error you're getting. You can now look at it as data and say, hey, that's a GenServer crash. Big improvement. And structured logging just gives you a lot more options. You can look at the data, you can slice it, you can dice it, you can transform it a lot easier because now it's data and it's not some kind of like format string you're intercepting. So here's a quick example of GenServer crashing. So you see it's a map. The label is GenServer terminate, the name of the process, the last message the process received, the state of the process, that's the one that might blow you up. The reason it crashed, the client info, which I think is why the client that was talking to the GenServer when it died. I actually don't remember how that thing works. And then crucially, we have some stuff like domain OTP. So we know that this came from OTP. OTP is originating this message. Here's the default report callback, which is GenServer format log. And then there's some, I really don't know why that's there. It feels redundant, but something about errorlogger is there. Okay, backwards compatibility, of course. Fair enough. So that's why that's there. You don't really have to pay attention to that. So now let's quickly talk about filters. Filters are, I really think of them, they remind me of writing like firewall rules for IPFW or PF. Really, you have basically, the filter can ignore a message, which basically just passes it through. In almost all cases, it can drop the message. It can say, I really don't want that. Or you can actually alter the message and transform it or do something to it and return the new message. And you chain the filters together. So it runs down the list of the filters you've got. And basically, if the filter makes it to the end of the chain, it gets passed on to the formatter. Unless the last filter in the chain returns ignore, at which point there's a configuration variable that will decide whether ignore means drop or pass. I think by default it passes. There are actually several filter chains. You have a primary one which is global to all handlers, and then each handler can have its own chain. And it runs the primary first, I think, and then it runs the per handler filter. I'm sure I'll be corrected if I've made a mistake here. And then filters are fun. You effectively, you pass in some state with them. But the state is static. The filter has no ability to update its own state. You could probably put an ETS table in there as the data to pass, but you have to be aware that this filter might be running in multiple processes on multiple times, and so you might have a data race there. So by default, I think traditionally you would just have a fixed value there. You could probably do some weird stuff, but be careful. And there are several nice default filters included in the standard library in a file called loggerfilters.erl. So unfortunately, as we've already mentioned, backwards compatibility is a thing. So the new logger looks a lot like errorlogger. It does not have oversized meshes protection by default. It looks like the old errorlogger. So all my complaints around, scaring users are still there. It has two bundled handlers, the standard handler, which is basically the console handler, but you can actually configure the standard handler to be a single log file that if you delete it, it will recreate, which is good. So you could do external rotation on it, and it should mostly work. And then my old friend disklog is still kicking. I've already complained about that. I would say if you are going to use the new logger, please read the documentation and please configure it not to be in legacy mode, because you can get better formatting, you can get better behaviors if you don't care about being compatible with errorlogger. So don't just blindly turn this thing on. I would suggest you look at how to use it and configure it correctly, because backwards compatibility is a thing, but you only have, as long as you're aware, you can disable that. It's kind of like being no compatible mode in Vim. So you can use an editor that's newer than 1974. So what's next for logger? Basically this new OTP logger has largely removed the reason for logger existing, which is good. However, there is still a lot of users of logger out there, so we have to figure out how do we get them off using logger. And logger has 8 years of development ahead of the new OTP logger. So it has all kinds of features. If you look at the logger README, it's extremely long now because every time we add a feature, we add it to the README file. So the README is now probably 20 pages long. So logger is ahead on features. There are some really nice features that definitely don't exist yet in the OTP logger. So today I'm announcing, it's not out yet, but Logger 4.0 will be coming out when I get enough time to finish it. I have a branch, but it's not, it actually works, but I'm still working on it. We're going to deprecate Logger's event core in favor of the OTP logger. The infamous parse transform will have a mode to rewrite all of Logger's calls into the OTP logger call format, and it will rewrite the metadata, put it in the right format. It all works. I already have this all working. I also have a report callback for formatting the OTP structured logging in the logger style, where it rewrites the big scary messages into slightly less scary messages. I have a bridge, so if you have an existing logger formatter, you can use it with the OTP logger with a little shim. And I think I'll probably try to provide some tooling around migrating and maybe sanity checking, or it's a little tricky, but I'd like to make it so it's easy for there's a smooth transition. If you have any ideas, please help me, because it's kind of complicated to change from one logging library to another. So this is kind of the cheat sheet, I guess. If you have an existing logger project and you want to switch to the OTP logger, these are really the handful of things you need to do if you want it to look exactly the same. So you effectively change your default formatter to the, and this is not going to be easy to print, obviously logger formatter. I'm sorry. And then if you want to overload the report callback to format the crash logs to be slightly more palatable, there is a logger formatter report callback, which will fix all of the OTP reports to look like logger prints them. And then in the logger stanza of your sysconfig, you will tell logger to use logger. And I know it sounds ridiculous, but what am I going to do? And then in your rebar config, and this is for rebar 3, I have no idea about any of these other things, so don't ask me about erlang.mk or mix. I have no idea. I don't even know about rebar 2, but just use rebar 3, and you just put this in here, And all of your set dependencies will also be recompiled to use the new OTP logger APIs. It just, if they used logger, they will now use logger, just like the flag says. So it will just upgrade. And I've done this and it works great. So why are we not keeping this thing alive? Well, we have a new one. It's fine. I don't want to split the community. I don't want to duplicate effort. I'd rather put features, missing features into OTP than keep maintaining my own thing. Everybody using the Beam can take advantage of the new logger. If you're using my logger, it's not so easy. It's kind of a weaker story. Also, it's been 8 years, 9 years. I'm fine with being done. Like somebody else, like Ericsson can have fun maintaining the logging library again. It's good. They haven't maintained errorlogger very much, so this is will be fun. So, community involvement. If you have any stuff using logger, if you've written your own backend or whatever formatter, the formatter you can just use with the bridge, but the backend, because the pipeline is different, you get a different thing. It's hard to provide a wrapper. So probably port your stuff. If you maintain a library that's using my logger, please consider porting it to use the new OTP logger. Be aware that you will break anybody running OTP 20 or earlier. If you're using logger, try my branch. See what works, see what doesn't work. And if you try to use the new OTP logger, please let Ericsson know if it doesn't work or if it doesn't address your concerns. I've talked to Siri, and they seem very interested in just knowing about what do users expect. They have a very enterprise and Ericsson view of the world, so I think they're open to other perspectives. Also, if you like to do blogs or podcasts or whatever, talk about this stuff, write documentation. The documentation is a little sparse right now. There's not a lot of good examples. Fred wrote a good blog post about doing structured logging, which I think is really good. There is documentation, it's just a little thin, especially filters are not well documented right now. So, pitch in if you can. It's going to be tricky to upgrade, but I think I think basically we should shoot for OTP 23. That'll be 3 major releases with the new OTP logger available. So next summer, I really think that we should expect our libraries to be using the OTP logger APIs. After OTP 23, I would like to cut logger 5.0, which would not even have an event core. It would be whatever bits that we haven't managed to get into OTP by then. That's all it would really contain. And just be aware that Erlang users like to stay on old versions, so they might get mad if you break their code by changing the logging API. Obviously, they have to come along at some point, but yeah, they will complain if you're not careful. So I wanted to wrap up by doing some benchmarking. This might be a little controversial. I've tried to be fair. My benchmarks may not be completely accurate. Benchmarking is really hard. But I had some old benchmarks laying around from 2011 that I dusted off to see what it looked like. So the two are Cascading Failures is an application that Fred wrote when he was at AdGear that emulated the failure mode that was killing nodes for them. Effectively, a process opens an ETS table and then spawns a whole bunch of children that all reference that ETS table, and then after a little while, it kills the ETS table. All the children try to read from the ETS table. They all blow up. The entire supervisor tree crashes. It all gets restarted, and it all happens over and over and over again. Crucially, it happens slowly enough that the supervisor does not hit the max restart intensity, and so it just really pummels the node until it runs out of memory and crashes. And then Logbench is something I wrote that basically just has different message sizes, different log backends, and basically it just sends a whole bunch of one kind of message through to a backend from a variable number of workers. So basically for cascading failures, I just wanted to look at the memory usage of 5 minutes of endless crashing. This test did kill errorlogger back in 2011. I don't think it dies now because of some of the depth limiting that's been added, but I didn't bother re-benchmarking it, to be honest with you. So this is Logger 4.0, alpha, whatever. Now the graphs are the units are gonna change on the graph because I couldn't figure out how to configure RRD tool. But basically you see that we stay basically below 120 megabytes. This is 5 minutes, and you can see each death spiral begin and over again. Now, one thing to note is Logger in this mode is writing to 3 different log files and to the console. It's has 4 handlers installed. This is console only, and you basically see that we just use very slightly less memory, but it looks very similar. The graph just does its own thing, but look at the axis, not at the height of something. And then if we look at the default config for OTP 21.2, it's not quite as pretty of a story. It spikes up to 600 megabytes, and then I think it realizes it's in some kind of terrible mode, and so it starts to kind of control things, but we still get pretty high spikes comparatively. Like we were at 120 megabytes, but you know, most of the time here we're well above that, or we spike above that very, very frequently. Then I tried turning on the max size and car limit, and this looks great, except we get almost no logs. It just, I don't know what, I think it goes into drop mode. Something is too slow or too much memory, and basically we get maybe 1/10 of the logs that we would expect. This is with the console again as well. I tried to write my own formatter, and then I don't know what happened. It said flush 5,000 log events, default switch to drop mode, and then all my memory went away, all my CPU went away, and my computer hard locked. So I don't know what's going on here. This is probably something I need to look into some more, but it's a little hard when you can't actually debug it effectively. So this might be my fault, but be aware that strange things happen with this test if you write your own formatter. I don't know why. We'll look into that. So yeah, I think I covered all this. Yep. So on to Logbench. So Logbench just sends a bunch of messages of different sizes to the back end and sees what happens. So this is with one log worker. Just for completeness, I'm benchmarking errorlogger here, just for old time's sake. And we have 3 different message sizes. So we have simple, which is a very small message, small, which is, I'll cover the sizes later, and then large. And you see that the performance, and this is effectively number of messages cleared through the pipeline per second. That's what the number is. It's not necessarily logged because these different loggers will do different things under overload. Some will drop, some will not. This is effectively at what point does the pipeline clear up? So we're really think of it a pipe. How many logs flow through the pipe a second? Some of them may go into the sewer because they're overflowing, but the whole point is how fast can we clear them out of the system? So we see that Logger itself is pretty fast here. It's one worker. The other thing that's interesting, we see we have errorlogger file, errorlogger console, logger file, OTP logger console, OTP logger file. Then we have a weird hybrid that uses the OTP logger pipeline with the logger formatter, which is the one that hard limits to 1 kilobyte. So we have 2 of those, one for console, one for file. And then we have the configuration where I've configured the built-in OTP logger size message limitations. And so you see that when the messages are large, and they're not all that large, but when the messages are large, you see that errorlogger and the OTP logger in the default configuration basically grind almost to a halt. Not quite. They do 22 messages a second, which is pretty slow, but they get pretty overloaded. And you'll see that my weird hybrid is actually the best under load here. And then just regular logger file handle does all kinds of tricks to be asynchronous and tricky, so it's actually very fast. When we have 4 processes logging as fast as they can, the OTP logger gets a big speed bump because it's doing the formatting in the caller. Errorlogger is still sludging along because it still has that broken pipeline. But you see that the other things have caught up. Logger is not that much slower with 4, or it's actually faster. Everything's faster, basically. But you'll see that the large number of messages, we've gone from 20 to 90-ish for the OTP logger. For the inbuilt size limiter, we've gone to about 2,000 per backend. Logger is about 6,000, 6,500. But then my weird hybrid is kicking ass over here for some reason. It's doing great. It's completely crushing everybody else. And the trend continues at 100 log workers. Again, Logger is basically kind of at the same level all the time. It's not really changing a huge amount. The others basically get faster. Again, though, you look at the large messages, you can only get about 100, 115 for the OTP logger. When you've got the rate limiting installed, it's only about 2,600 versus you get 10 times faster with my size limiter, which is interesting. And then I tried to send really, really big messages, huge and giant. We'll cover how big those are in a little bit. But again, I could only benchmark these two. The others do not actually survive. It takes so long that I gave up. I had to run these benchmarks a lot. They took hours, but I only had so many hours to run these things. So we're clearing about 5,000 messages a second with the hybrid, and Logger is going about 1,500, 2,000. That's with one worker. We go to 4. Weird things start to happen. You see the red getting tall like that means that actually we're not writing every log out now. We're starting to shed load. And then at 100 workers, we go into like panic mode, and we just start throwing stuff out the window, which is fine. That's good for the system. I mean, you can't necessarily expect to log everything. So you will go into overload condition, and very few of these logs actually get written. But the point is that they're getting flushed out of the system. They're not eating your RAM. They're not eating your CPU. The logging is not consuming all resources on the beam, which is, in my view, important. So back to the large files, large messages. If I graphed the memory usage of the OTP logger in console mode during the test, and you see that it goes up to about 900 megabytes and just sits there for the duration of the test. Similarly for the file. This is in the default configuration. So be aware that you may use a lot of memory with the default OTP configuration for OTP 21. The others were much lower. I didn't include them because they weren't super interesting. But these were the outliers. So just to cover the sizes, the simple message is 5 bytes, the small is 56 bytes, the large are about 96 kilobytes, the huge are 4 megabytes, and the giant are 16 megabytes. And as I said, Logbench is measuring the flow of messages through the system, not necessarily that they made it to the endpoint. Overload protection may have kicked in. I could have turned off overload protection, but I was kind of interested in what is the default, what do these things do by default? So one thing that we learned here is that the built-in OTP logger message size limiter is really quite slow. I've talked to the OTP team about this. They're aware of it. They're working on it. 21.2.6 is faster, and then there's a branch that's even faster. They're working on it. It's still not as fast as the thing that I hybridized together. That's still the winner, but they're working on it. They're aware of the problem. They've seen this benchmark. They're aware. Yeah, so without message size limiting, you're gonna get yourself into trouble. It doesn't take much to start things kind of getting into a bad feedback loop. Good thing is that the OTP logger does ship with overload protection by default, so it will start to shed load at some point, but you may only get 20 messages a second out of the thing. So just be aware that there are some speed concerns. And as I said, the weird hybrid is the fastest thing. Not exactly, well, it makes sense, I guess, but because my size formatting or my size limiting is much faster, but because I spend a lot of time on it. So that's an interesting thing to take away. So yeah, here's the wrap up. Logger is still, the OTP logger is still pretty new. It still needs work, and it still needs users to give feedback to Ericsson to say this is something that I need or this isn't working well. It's also got some features it's also missing features comparable to Logger. So if you switch, you may be missing features, just to be aware. I don't categorize the default configuration as safe. I know it's backwards compatible, but I urge you to look at that config and change it because it will bite you in the ass at some point. The other thing is if you have a lot of handlers installed in the OTP logger, they all cost. They all incur cost versus you can have a lot more handlers installed in Logger and they're relatively cheap. So if you're currently using Logger, be cautious about switching just yet. Take your time, categorize what the performance is going to be like. If you're using the OTP logger already, just check your configuration, beat on it a little and see what it does. If you're still using errorlog, just anything is better, please. Just upgrade, please. And I think, you know, my real takeaway from this talk is let's try to get everybody working on the OTP logger. Let's put all the effort behind that thing. Let's make that thing better and stop having so many out-of-tree log libraries. Let's just make the standard library logger better, and everybody wins. That's my talk. I don't know if we have time for questions.
We have 4 minutes for questions.
All right.
So what are your thoughts on, I'll say, called modern supervisors, like systemd with logger D, like a journal D, or maybe Kubernetes with its own logger? So like with journal D, we would be maybe writing to a Unix domain socket instead of a file, and theoretically we can send as much data as we like, but then it fills up. And maybe we could even be writing from all the processes at once, and we don't have a central bottleneck.
If you could repeat some of it.
Yes, the question was systemd and Kubernetes, and if you're not logging to a discrete device like the console or a file, can you maybe just avoid the bottleneck? And the answer is yes. I mean, I don't like systemd, and I don't think it's good, but it does, you know, if you want to do it that way, and you can push your logs just over UDP and it's not a blocking interface, you can do that all day long. And in fact, what you can do is you can use a filter to send, your filter can instead never actually forward to a handler. You can, in the filter, just send UDP. You know, you pass the socket in as a filter argument, and you never leave the calling process. So the calling process is just sending UDP. Now, of course, if your UDP stuff can break or do some weird things, you might have trouble, but you don't always have that luxury, though. And obviously, at some point, queues are always, there's always an unbounded queue somewhere or a queue that's going to fill up, and it's always going to get you someday, whether it's DNS or it's UDP or it's the switch, you know, getting clogged with log packets. But sure, don't log to disk if you don't have to. If you have more infrastructure for that, ship it off somewhere else. Absolutely.
Can I add something to that? Actually,
sure.
Handlers are called in the calling process. There's no implicit process hop when doing a handler.
Oh,
So
okay.
the process hop is something that the handler implements and not something that's part of it. So all the filters and all the formatting and all the filters on the handlers is done in the calling process. And then the process hop is something that you implement there, because we do logging in LTTNG, and then we do these things that they talked about there.
Okay, so just for the record, I have a mistake in my slides, and there is not always a message passed to the handler. I think that's part of the overload protection mechanism. You can write handlers that do not use that behavior, and they will not make a message call, which is good.
Have you run the benchmarks on 22RC?
No, I ran out of time. Sorry, and also it came out after I was done. I was sick of benchmarking. I will probably put together. Oh, so the question was, have I run them on OTP 22RC1? I will probably put all this together in a blog post and try to be a little more scientific about some of it. I ran out of time, but I will benchmark OTP 22 as well.
One last question.
It's okay if you don't know this.
Will I get a red card?
It's like an Elixir thing. No, you're getting a green card. You said the Elixir logger is using the OTP logger underneath, but does that still have the legacy configuration when it ships? And you have to do some weird, like, Elixir sysconfig double.
The question is, does the Elixir logger ship in legacy mode? I don't know. I would encourage you to find out. Because, yeah, things.
I know they don't use our logger at all yet.
No, they do. They do.
In part, they take our messages, but they still have backward compatibility issues with their interface, so it's not all in there.
Oh, okay.
So the answer is undecided, it sounds. Okay.
Multi.
All right. Thank you, Andrew.
Thank you.